Okay, good morning everyone. For today we're going to have solving word problems. This is the parabola applications. And this is your math teacher, Sir Topper, at your service. Okay, let's start with a paraboloid is formed by revolving a parabola about its axis. A spotlight in the form of paraboloid, 5 inches deep, has its focus 2 inches from the vertex. Find to one decimal place the radius r of the opening of the spotlight. So you are given this scenario. This is paraboloid. This is also in different aspect. Okay. So in illustration, we have this one. Locate a parabolic cross-section containing the axis in a rectangular coordinate system and label all known parts and parts to be found. Okay, so this is the distance, -5, 5, and this is 5 from this vertex, and this is the radius. So you are going to look for the value of your r. So find the equation of the parabola from the figure. Since the parabola has the y-axis as its axis, and the vertex is at the origin, the equation is of the form x squared equals 4ay, wherein the focus is 0a. So when we are going to take that, the focus is 0, 2. Then a is 2. And the equation of the parabola is x squared equals 8y. Okay, can you follow? Use the equation found in step 2 to find the radius of the opening. Since you are given an ordered pair, r5 is on the parabola. So we have r squared is equal to x times 5. Okay. Then simplify further, we have r equals the square root of 40. And to simplify for the square root of 40 further, we have 6.3 inches. Therefore, the radius of that paraboloid is equal to 6.3 inches. Okay, any question? Okay, let's proceed with number 2. A parabolic arch has a height of 20 meters and a width of 36 meters at the base. If the vertex of the parabola is at the top of the arch, at which height above the base is it 18 meters wide? Okay, so let's add the illustration. So this is the illustration of the arch. This is the below and this is the above. Okay, and this height is from this point to that point is 20 meters. Okay, and we're going to have the x and y axis here. So the center is at 0, 0. So this is the so-called 18 meters. So if this is 20 meters, somewhere here. So let's have this point and that point is the 18 meters. Okay. So therefore, this point from here is negative 18, 0. And this point from this vertex is 18, 0. With the span of 36 meters. Okay. When we say span, distance, we talk about the positive value. Okay, and this point is the 9 and y. So the question is, what is y when x equals 9? So you're going to use this equation. X squared is equal to 4a times y minus 20. Okay, and the parabola contains the points positive, negative, or plus minus 18, 0. And by substitution, we have square of x, which is 18, and then for a, we don't know the a, 0 of y value because of this, then minus 20. So simplify further. This is divide both sides by negative 20. So we have 18 squared over negative 20. Then 4a equals negative 81 over 5, reducing it. Okay. Use x squared equals 4a times the quantity y minus 20 when x equals 9. And 4a is negative 81 over 5. And by substitution, we have x squared, this time is 9. So inject it here. Then 4a is negative 81 over 5. Then copy y minus 20. 9 squared is 81 equals negative 81 over 5 times the quantity y minus 20. Okay, so simplify further. So we have, okay, remove 5 here. So we're going to multiply the equation by 5. So we have 5 times 81. Then divide the equation again by negative 81. So we have negative 81. So we are left, or we are on the left side, we are just having y minus 20. Simplify 5 and 81, or simply this one will be cancelled. 81 by negative 81, it is negative 1. Negative 1 times 5 is negative 5. And therefore, you transpose this one to the right, so it will become positive. So we have negative 5 plus 20. And you add the 2, and you will have the sum of positive 15. Hence, the arch is 15 meters tall when the base is 18 meters wide from the center. Okay, can you follow? Okay, it's very easy. Just follow the patterns, the formula, and the procedures. Okay, so you are given here as it work. Parabolic arch in a concrete bridge must have a clearance of 50 feet above the water in a span of a distance of 200 feet. Find the equation of the parabola after inserting coordinate system with the origin at the vertex of parabola and the vertical y-axis, pointing upward along the x-axis of the parabola. And this is the illustration. So this is same as example 1. So you can do that. Just follow the procedures step by step. And this one, the cable suspension bridge hangs in the form parabola. When the load is uniformly distributed horizontally, the distance between two towers is 150 meters, and the points of support of the cable on the towers are 22 meters above the roadway, and the lowest point on the cable is 7 meters above the roadway. Find the vertical distance of the cable from a point in a roadway 15 meters from the foot of the tower. This is same as example number 2. You can do that. Again, follow the patterns and the procedures. And for your assignment, you're given by this: a designer of 20-foot, 200-foot diameter parabolic electromagnetic antenna for tracking space proves wants to place a focus 100 feet above the vertex. Okay, so I think you will follow or proceed with the procedures. Just follow it step by step. Okay, so if you don't have any question, so let's say good morning to all of you, and this is our topper at your service.